Okay, so we learned about common tangents and their properties and tangent circles. Now we're going to work a couple of problems and a couple of proofs involving those properties. First, given that zx is a ray that is a common tangent, xw is 20, yv is 10, and yz is 24. Find xz, xy, zv, and wv. If zx is a common tangent, what does that mean? That means y must be a point of tangency and x must be a point of tangency. Knowing that those are points of tangency and wx and yv are both radiuses, we know that we must have right angles at x and at y. Now let's label our lengths. xw is 20. YV is 10, and YZ is 24. How are we going to find these lengths for XZ, XY, ZV, and WV? Well, you kind of have to recognize in this problem that there's two triangles. We have the triangle YVZ is a small triangle, and we have the triangle XWZ as a big triangle. Now we already know that they have a right angle in common. Now these triangles aren't the same size, they're not congruent, but they do share two common angles, or two congruent angle measures. Angle Z would be reflexive for both triangles. So we can use the angle-angle similarity property, and we could say that triangle XWZ would be similar to triangle YVZ. Now, what's the property we know about similar triangles? Similar triangles, all of their side lengths are proportional. So we can set up a proportion to solve for all of our missing lengths. First, let's do XZ. X to Z. Well, we know YV over XW should be proportional to YZ over XZ. So now let's just fill in and solve. XW was 20, YV was 10, YZ was 24. Let's solve for XZ. The easiest way to do this would be to find the scale factor for the two similar triangles. If we reduce 10 over 20, we get 1 over 2 equals 24 over XZ. Cross multiply, 1 times XZ would be just the segment XZ, the length of XZ. 2 times 24 is equal to 48. So XZ must be 48. Now let's solve for XY. Let's solve for XY. I'm going to use the same two sides to set up my proportion. And actually, I don't need to use the same two sides because we actually set up a scale factor. We know the scale factor from the small triangle to the big triangle is 1/2. So let's solve for XY. XY is this length here. We don't know what XY is. I'm going to label XY. And actually, looking at this problem now, I don't even need to do that. If I know that XZ is 48 and YZ is 24, I can just use the subtraction property and say that XY must be 24. ZV, I'm going to have to use a different property. Let's see, what kind of triangle do we have? If I look at just the triangle YVZ, we knew this was a right angle. We knew that this is 24, and we know that this is 10. So I have two sides of a right triangle. What do we use to solve this? We use the Pythagorean theorem. Or, if we know our triples, 5, 12, 13. The short side is 10, the short leg is 10, the long leg is 24. So how long must the hypotenuse be? Well, 5 times 2 is 10, 12 times 2 is 24, so 13 times 2 must be 26, so VZ must be 26. Now we've got one more to solve for, and that would be WZ. A couple of different ways you can solve for this one. I'm going to use my scale factor of 1/2 and find the length of WZ and subtract. I know that the whole length of XZ is 48 and WX is 20. So let me set up my scale factor of 1/2 equals 26, which is VZ, over the whole length WZ. Cross multiply. WZ times 1 is just WZ. 2 times 26 is 52. So if WZ is 52, then WV is equal to WV is equal to WZ minus VZ. So WV would be equal to WZ, which is 52, minus 26, which is 26. All right, let's move on to a little bit more difficult diagram. BC is a common tangent. That means it's common to both circle A, tangent to circle A and circle D. AB is equal to 4. So let's label this 4. We know B is a point of tangency, so this would be a right angle, and we know that C is a point of tangency, so this must be a right angle. AE is equal to 17 over 2. BE is equal to 15 over 2. And CD is equal to 5 over 2. We have to solve for EC, ED, and BC. I'm going to set this one up a little bit different. I'm going to say that EC is equal to X, ED is equal to Y, and BC would simply be BE plus EC. Once I find EC, that will be really easy to solve for. All right, well, how are we going to solve this problem? Well, again, we know we have two right angles in each triangle. Do we have another angle that's similar where we could set up a proportion using the properties of similar triangles? Well, let's look right here at E. We have this angle, AEB, and let's look at angle CED. What are these type of angles? These are vertical angles. What do we know about vertical angles? That they're congruent. So these two angles are congruent. Well, if angle ABC and DCE are both right angles, we know that they are congruent. So angle ABC is congruent to angle DCE because all right angles are congruent. Now that we have two congruent angles, we can set up the similarity statement. Using angle-angle similarity, we could say triangle ABC is similar to triangle DCE. And using the properties of similar triangles, we can set up proportional lengths. So, AB would correspond to CD, so we can use the fact that 4 over 5 over 2 would be equal to any other segments that we could set together. What does EC correspond to? What does X correspond to? Now that's on the small triangle, and so it's going to go on bottom this time. This time I set it up as big over small, the big triangle over the small triangle. You can set it up either way you want to. I just chose to do it this way this time. So EC is small, so that's X. And what does EC correspond to? EC corresponds to BC. How long was BE? Excuse me. It should have been BE. ABE. BE is 15 over 2. So let's solve for X. Cross multiply. 4X equals 5 over 2 times 15 over 2. So 4X equals 75 over 4. Now how do we solve for this problem? We multiply by the reciprocal. Property of reciprocals tells us that 1/4 time, any number of times its reciprocal is just 1. And then we multiply our fractions on the other side. Can you reduce that fraction? Is there anything that goes into 16 and 75? 2 doesn't go into both. 4 doesn't go into both. 8 doesn't go into both. So, no, 16 doesn't go into 75. So, X equals 75 over 16. And X corresponded to EC, so EC is 75 over 16.